All right, let's get right into it. We're living in this wild time where computers can write poetry, they can generate code, they can even hold conversations that feel, well, shockingly human. But here's the twist. What if I told you that behind all that magic, the machine doesn't understand a single word it's writing? I know, it sounds completely impossible, right? This is the big question, the central mystery of modern AI. How can a system with zero comprehension, absolutely no real-world experience, produce text that is coherent, creative, and sometimes just profound? Well, the answer isn't some kind of magic, and it's definitely not consciousness. It all boils down to a single, brilliant idea called the transformer. It's a specific type of neural network, an architecture that was introduced back in 2017, and it just completely rewrote the rules. So let's forget everything we thought we knew about how computers handle language. The transformer is the secret ingredient, and we're about to break down exactly how it works. Okay, so first things first, we have to understand the fundamental job of a large language model, or an LLM. It's not about thinking, it's not about reasoning. It's really about playing a very, very sophisticated guessing game. That's it. That is the entire goal. So when you ask something like ChatGPT a question, it isn't thinking about an answer. What it's actually doing is calculating, one single word at a time, what the most probable next word should be to create a sensible response. And it does this based on the billions and billions of text examples it was trained on.
Think about it like this. If you read the sentence, "The cat chased the," your brain just instantly fills in mouse or maybe ball. An LLM does the exact same thing, but with just this staggering mathematical precision. It generates a probability score over thousands of possible next words, and then it just picks one. It's all statistics, not sentience.
So if it's just about predicting the next word, why is this all happening now? Why is this so new? Well, before the transformer came along, AI models had a really serious memory problem. They just couldn't keep track of context over long sentences. The old models, things like RNNs and LSTMs, they were kind of like a conveyor belt. They processed a sentence one word at a time in a line. And by the time they got to the end of a long paragraph, they'd often forgotten what was said at the beginning. But transformers, they're totally different. They're like an information web. They look at all the words in a sentence at the exact same time, instantly seeing how every single word relates to every other word. This ability to process everything in parallel, that changes everything.
So how in the world do they see everything at once? This brings us to the core innovation, the absolute heart of the transformer. It's this incredible mechanism called attention.
See, in any sentence, some words are just more important to the meaning of other words. Attention is the process that lets the model weigh all these connections to figure out which words should pay attention to which other words. It's how it builds a deep contextual understanding of the whole picture.
The more technical term for it is self-attention, and you can almost think of it as every word in the sentence getting to talk to every other word. This lets them pass information back and forth, updating their own meaning based on the full context of the sentence, not just the words right next to them.
You know, a simple old-school model might only see that the comes before Matt, but an attention mechanism can instantly draw this super strong connection between cat and Matt because it understands that the subject of the sentence has a direct relationship with that object no matter how many words are between them. Now that is true context.
Okay, let's actually pause here for a second because this is the most important part. The model pulls this off with a really clever three-step process for every single word. First, a word creates what's called a query. Think of it like the word asking a question, like, hey, who in this sentence is relevant to me? Then every other word generates a key, which is like it's raising its hand saying, here's what I'm about, maybe I'm the answer you're looking for. The model matches the query with the most similar keys, and finally, the words that have the best match pass their information along using their value. It's this dynamic, lightning-fast system for figuring out relevance across a whole text all at once. So we've got this incredible attention mechanism that can see every connection. But why does a system that's just spotting patterns in relationships feel so intelligent? Well, the answer is scale, a truly mind-boggling, almost unimaginable scale. Take a look at this number. That's the number of parameters in a model like GPT-3. You can think of these parameters as tiny little knobs that the model gets to tune during its training. And with 175 billion of them, the model has this unbelievable capacity to learn and store the statistical patterns from basically the entire internet. And when you combine that massive scale with the transformer's amazing ability to see context, something incredible happens. You get what are called emergent abilities.
These are skills that the model was never explicitly programmed to do. It learns to write code, not because anyone taught it C++, but because it has seen so much code it just figured out the statistical grammar of it. It can mimic Shakespeare because it's learned the patterns of his style. This is the real magic. Scale meeting a superior architecture.
And this brings us to the crucial point. When a human uses a word like love, we are referencing this abstract concept built on emotion, experience, biology, the whole shebang. But when a transformer uses the word love, it's referencing a single point in a vast mathematical space, a point that is defined purely by its statistical relationship to the billions of other words it has seen next to the word love. It's pattern recognition, not feeling.
This is the classic, absolutely mind-bending example of how this all works. The model learns that the direction in its mathematical space that takes you from the concept of man to woman is the same direction that takes you from king to queen. It hasn't understood royalty or gender. No, it has learned the relationship as a kind of geometric logic. It's a type of meaning that is completely alien to how we think. This ability to learn relationships at an immense scale has already fundamentally changed our world. But the transformer isn't the end of the story. It's the powerful foundation for whatever comes next. It's proven that the key to unlocking AI performance wasn't about perfectly mimicking a human brain, but about building a better way to see connections in data.
You know, for decades, we've been totally obsessed with that one question, framed by this idea of replicating human intelligence. But maybe, just maybe, the transformer is telling us we've been asking the wrong question this whole time.
Perhaps the future of intelligence, both ours and the artificial kind, isn't about creating a machine that thinks like us. Maybe it's about building tools that can see the intricate web of connections in the world in ways we simply can't. The transformer is the first giant leap in that direction, and it leaves us all to wonder, what other patterns are out there, just waiting to be seen?